So in this problem, we're asked to determine whether the series, the sum from n equals 1 to infinity of 2 to the n over n factorial, whether this is divergent or convergent. Now, for this problem, we want to use the ratio test. The ratio test will not always tell you whether or not a given series is convergent or divergent, but for this type of one, where you get a lot of cancellation between neighboring terms in the series, for this type of series, it should give a conclusion. So for the ratio test, we examine the limit as n goes to infinity of the ratio an plus 1 over an. Okay, where an is the nth term of the series, 2 to the power n over n factorial. So we want to determine the value of this limit. So the term an plus 1 is 2 to the power of n plus 1 over n plus 1 factorial. And when we're dividing by an, well, we just multiply by the reciprocal, 1 over an. Oh, I forgot my limit operator in here. So we're taking the limit as n goes to infinity of all of this. Now that's quite a complicated term at the moment, but the point about it is that there's a lot of cancellation here. The powers of 2 are going to cancel out, leaving you with 1 factor of 2 in the numerator. The factorials are going to cancel out as well, because all these factors in this factorial, n times n minus 1, etc., they're all contained in this factorial here. So we can cancel out all those factors, and we're left with just the factor n plus 1 remaining in the denominator. So that's just doing the cancellation. Now this limit, well, okay, it's a constant over n plus 1. So as n gets bigger and bigger, this term is going to be getting smaller and smaller and converging to 0. So this limit is 0. Now in the specification of the ratio test, we give the name L to this limit. And since L satisfies the necessary property that it's strictly between 0 and 1, we can say the ratio test implies that this is a convergent series. This is a convergent series. Okay.